So, right, we want to get our V, right, for available resources, right? So same thing, right? We have R, right? You got to use the formula, right? V is equal to R minus A, right? So we just know, right? We know it's going to be 0, 1, and 3, right? And now we want to find our Q, right? So our Q is just going to be C minus A, right, for every value. So this is going to be 2 minus 1, right? So it's going to be 1, it'll be 2, it'll be 0. Right? You guys have any questions? I got this. Great. Great. So this for every row.
But it took me a second. First, I recognized. How you doing?
1, 0, and then this will be 1. Okay. 2, 0, 1. Okay. Same thing. Our third row will be 0. Let's see, 0, 1, and 1. Same. Repeat it. So 0, 1, 4. And the last one should be 0, 1, 0. Right. Great. So now we have everything to do to work Banker's algorithm, right? Compare our available resources against our C minus A, right? So let's compare, right? We see that 1 is greater than 0, so right there's a deadlock. So we'll come back to it. Go on to the next one, right? 1 is greater than 0, so there's a deadlock. But then we look on here, we see that this is greater than or equal to C minus A, right? So then we can update our available resources, right? So we're going to add 0, 1, our available resources to that process at that row. So we're going to add our available resources to the allocation process at 3. Right, so we're going to have, right, the 0, 1, 3. So now it's going to be 0, 1, 4. Right, if you see, right, so we're going to put 0, 2, 4. Hold on. Did we move around? Check 0, 1, 3. No, it should be 0, 1, 4. Yeah, it should be 0, 1, 4. Yes. Right, 0, 1, 4.
It's just
Right, so
that you add all of them to the V matrix.
right, so our updated V is here. Right, so this will be our new one. So let's compare. Right, is this greater than or equal to C minus A? Yes, it is. So we're going to update our V again. So now, right, we added it here. So we're at that the allocation at that process. So it'll be process 4. So it's going to be 0, 3, 0, 3, and 4. 0. Oh, no. Is it? First updated it? Let's see. Whoops. Let's see. Check. Yeah. Wait, hold on. Oops. What the mess? All right. Can you zoom in with 0 to 4? 0, 1, 3 plus 0, 1, 1. No, should be 0, 0, 1. Remember, you're adding the allocated resources. Right? That should answer your question. That's not very. Right. So 0, 3, 4. Right. We move on. Right. This is greater than or equal to our now available resources. Right. We compare it again to process 5. Right. And it's greater. Right. So this is good to go. So then we update it. So it's going to be 1, 1, 3, 5. Right. Now we'll come back to process 1, which was deadlock. Right. So we're trying to avoid that. So let's check again. Right. This is greater. So right, we update its resources. So this is going to be 2, 4, and 6. All right. So now we're good to go. So there you go. We're good to go. So move on to the next row. And then we'll see that this is greater. So now we can update our V one last time. So this is going to be 3, 4. What's it? Oh, sorry. 3, 3, 4, and Let's see. Let's see, wait a minute. Oh no, where my math go wrong? No, wait. 3, 3, 4. Let's see. Flip side, wait. Let me see. 0, 2, 4, 6. Yeah, 3, 5, 7. Yeah, sorry. There you go. Yeah, I messed up my math somewhere. I bet, but yeah, should be 3, 5, 7. Right. Then great. Now there's no deadlock here. Sorry, messed up my math. Let's see, 2, 4, 6. Let's see, 0, 2. Yeah, there you go. This should be 5. There you go. Sorry. That should be it. There you go. There you go. That should be it. Right. And then now, okay, everything is great. So now our final V will just be 3, 5, and 7. And then in the exam, it'll ask you if this is safe, right? So if it's safe, that means there's no deadlock detected. So it's safe. Any questions on Banker's algorithm? All right. Let me see. I think there is one little edge case. Let me see. Hold on. So let's say if one of the, let's see, oops. Let's say, for example, let's see, like hypothetically, right? Let's say this is 3, 5, and 8. Okay, hypothetically, right? If our available, and this is still deadlocked, right? If our available resources, as we see, right, this 8 is not greater than 7. I'm sorry, 7 is not greater than 8. Then there's a deadlock, and we can't avoid it, right? So then this will just be not safe. So it'll be false, right? But I don't think that should happen. So I think you guys should be fine. So let me just update this back. It was. So you want to. Okay. And yeah. What if one of the allocation row is 0, 0, 0? Yeah, this should be safe. I think so, right, Cameron? This should be safe if the allocation row is still 0. If all the rows still all zeros.
For oh yeah. It's like that for
Okay, then
every
yeah,
rule.
the same rule follows. Yeah, so unlike deadlock detection, you're trying to find a deadlock. Right here, we want to avoid a deadlock happening. Right, this doesn't mean a deadlock won't happen. Right, we have to figure that ourselves. But here we're trying to avoid a deadlock. Right, so that's pretty much the main difference. Let's see, is there any more questions? Yeah, C minus A is the same as Q. Yeah, but you're not giving Q in bankers, right? So you got to solve that. But it's just C minus A.
It's like literally the same thing as deadlock
Yeah.
detection, except like 2 extra steps. You're doing the same thing. It's just your Q is C minus A. And then you're comparing that to your V. And then whatever, if it's greater, you're updating the V with the A. It's the same thing.
Hey,
Okay.
real quick, explain the first row of V. How'd you go from 0 to the 1, 2, and 3? Like, where did you reference that for A to get it?
For which part? Let me see. Where?
Column, the first column of V.
Hmm.
Yeah, and that whole column. How did
Oh,
you
this is just the.
no,
Oh, this is the same.
not the first one specifically, but like the where'd you add? Like, what did you add?
Oh,
The other, yeah, 1, 2, 3.
so it's the same thing as deadlock detection, right? So, right here we see a deadlock here, right? We can't update our available resources. Same thing here, but process 3 at C minus A, right? Our available resources is greater than this, so we're just going to add the allocated resources at that process. So we'll add 0, 1, 3 to these values, right? So we get 0, 1, 4. Does that answer your question?
Yeah. Keep doing that over and over again, and that's how you get.
Uh,
The,
yeah,
that's how you got the
you
other
keep yeah,
one.
you keep going until. right? You keep going till you want, till you reach the final state, which is our final V. So C is the same thing as Q and is Q. Well, I mean, C minus A is the same thing as Q. C is just like the max demand of our resources and bankers. It's just like Cameron said, this is just more like extra steps.
So
I mean,
we
they're.
compare.
Oh.
Go ahead.
No, you're good. You're good. Go on.
So on this, we compare V to CA, not opposite.
No, here it's the same thing as deadlock. So you're going to compare V. Yeah, you compare V to CA, yeah. And then if this is less than, if our available resources is greater than C minus A, then we add the resources at that process, right? So you see here, right? Our available resources is greater than at process 3. So we're going to add the allocated resources, right, at that process. So we process 3.
So C minus A needs to be smaller than V?
Yes. So in order to add it, that should be right here. And I'll send the document also, so you guys, there's like I have another example for you guys to solve. So it should be good.
The reason this exists, right? Because I think some of you are probably like, why would we do this? If it's the same thing as deadlock. In actual practice, like he said, this is to avoid. This is a practice to avoid deadlocks. This actually, if you're writing code or whatever, using this banker's algorithm will help you avoid deadlocks. Whereas deadlock detection is something you run on your processes to detect if a deadlock would occur. So that's why you're learning the two different things. They're very different when implementing them, but mathematically and like solving them, they're virtually the same thing. Okay, so don't get too confused or don't try to psych yourself out with it.
All right. Any more questions on banker's algorithm? Let's see, one person's typing right now. We'll just see what they have to say, and then we'll move on to the next topic. See for the extra credit.
Yeah, you can. You just have to submit it at the end of the thing.
And also make sure if you guys are using Excel, make sure don't make sure to type slowly and don't put miss and put a number that could really mess everything up. Right, see here if we got 357, but let's say you got what I did, right, 347, right? Then that would mess everything up. So just be careful with that if you're using Excel. If you want to say, went back and check the rest of the dialog. Yeah. All right, and then we'll go over one free response question that you guys will see in the exam. So if there's no more questions, then I'll go to it. Right, so this is straight from your practice exam, right? So you're gonna see this question in the exam. Is identify the number of critical sections and the shared resources detected by the critical section, right? A simple way I think of it is the number of critical sections, right? If there's a lock and unlock, right? That counts as a critical section, right? So it just falls in between there. So we look at this snippet of code, right? We see there's one mutex lock here, right? An unlock, another one at line, we see, and this at after sleep 5, and then another unlock, right? So there will be 2 critical sections, right? This should be really pretty straightforward. Does anyone have any questions on how I got 2 critical sections? Let's see. No. Okay. And then you're gonna be see. Yeah. So remember, the critical section falls between, right? If there's a lock and unlock, right? That's the way I think of it. Oops.